Hello everyone, I am Sahit Akash Mankanta. Today we are here to share our presentation with you how a desktop computer is built and know more details about them. Let me introduce you to our dynamic team Manoj, Rahul, Sundaram and Ankit. This is how an actual PC is built. Let me show you a video how an actual PC is built. So agenda of our today's topic is CPU, motherboard, memory and storage devices, GPU, PSU, computer case, cooling system, input and output devices, expansion cards, ports and connectors, and operating system. First of all, let's go into the first topic of our agenda, that is CPU. CPU stands for Central Processing Unit. That is also called the brain of a computer, which processes data given by user and produce. Coming back to the history of a CPU, since 1823, when Baron Jobs Jacob Bergelius discovered silicon, which is still a primary component which is used in the manufacture of CPU today. In January 1999, Intel introduced Kernel 366 MHz and 400 MHz processors. AMD back in April 2005, which with its first dual-core processor. Intel released the first core i5 desktop processor with 4 cores in September 2009. Let's go into the parts of a CPU. CPU mainly has 3 parts, which include ALU, CU, and MU. ALU stands for Arithmetic and Logic Unit. The ALU in computer are capable or responsible of performing multiplication, subtraction, and etc. CU, control unit. It controls all hardware operations on any computer, like input, output, storage, processor itself. MU stands for memory unit. Memory unit stores all data and instructions that need to be processed. Now coming to the types of CPU, there are mostly 3 types of CPU. Single core CPU. This have a single core which is used to processing data, and dual core has a 2 cores, and a quad core has a 2 dual cores. And my friend Ankit will continue his part of motherboard.
Hello, I am Ankit. I will be discussing about the motherboard. Basically, a motherboard is the main printed circuit board PCB in a computer. The motherboard is a computer central communication backbone connectivity point through which all components and external peripherals connect. Motherboard can be found in virtually all computers, especially desktop, laptop, PCs. The components that connect through them include chipsets, central processing units, and memory. And after that, we have history of motherboard. The first motherboard, originally called a planar, was used in the IBM personal computer. The AT advanced technology, a full AT motherboard form factor, which was introduced by IBM in August 1984. NVIDIA introduced its SLI, Scalable Link Interface Technology, in 2004, along the ability to link two video cards together on a motherboard. IBM released the HPTX motherboard factor in 2010. Now we have parts of motherboard. Basically, it includes CPU, memory, storage interface, ROM BIOS, north-bridge, south-bridge chipset, cooling fans, peripheral connector, backup battery, and power connector. Rest of the content you can get from slide only. Now my friend Rahul will continue on RAM memory.
Hello everyone, I'm Rahul. I'm going to explain you about RAM and storage devices. Let me start with RAM. RAM. It is alternatively called main memory, primary memory, or system memory. RAM. Random access memory is a hardware device that allows information to be stored and retrieved on a computer. RAM is a volatile memory and requires power to keep the data accessible. RAM is usually associated with DRAM. It means dynamic random access memory. Let me move to the next slide. Let me come to the history of RAM. The first form of RAM came about in 1947 with the use of beryllium tube. It utilized a CRT cathode ray tube. The data was stored on the face as electrically charged spots. Then second widely used form of RAM by magnetic core memory and was invented in 1947. However, RAM, as we know it today, a solid-state memory, was first invented in 1968 by Robert Dennard. Known specifically as the dynamic random access memory or a DRAM. Transistors were used to store bits of data. Let me move to the next slide, where we are going to see types of RAMs. Over the evolution of computers, there have been very different variations of RAM, such as DIMM, RIM, SIM. You can read these lines in the slides, but below you can see an image of 512 MB DIMM RAM computer memory module, a piece of RAM found in older desktop computers. This memory module would be installed into one of the memory slots on a motherboard. Let me move to the next slide where we are going to see storage devices. Storage devices, there are mainly two major types of storage devices used in today. One is HDD and one is SSD. Let me come to the HDD. HDD stands for hard disk drive. It is a type of storage device generally used in old PCs, or now SSD have taken place of HDD because HDD are quite modern and they are just fine as possible. Let me come to SSD. Actually, SSDs are also quite quicker, consume less power, and have more benefits than HDD. Let me come to the next point. First, we come to the history of SSD. History of SSD. Over the, you can see the evolution of SSD. In 1950, the core memory and the card's capacitor read-only store CROS. In 1980, SSD were implemented in semiconductor memory for yearly supercomputer of IBM and Cray. In 1978, Texas Memory System introduced a 16 kilobyte RAM solid-state drive to be used by while companies for system data acquisition. Then it's come 1995, where M System introduced flash-based solid-state drives, which is usually used in the today modern days. And then 2003, terabyte SSD become commercially available in February 2003. Computer Texas Memory System and Verica Technology announced the world's first terabyte class SSD. In May 2006, Samsung launched the world's first high-volume Windows XP notebook using SSD. Let me move to the next slide. We will come to see the history of HDD. Actually, HDD were introduced in the 1950s. Hard drives were invented by a team of engineers working at IBM under the leadership of Reynold Johnson. We can see that HDD are often called fixed disk. The first hard drive capable of storing entire gigabyte was IBM 3380. It was released in 1980. However, this machine was quite big. It was a side fabricator and the cost tens of thousands of dollars. It was quite expensive. Then we come to the next point where we are going to see the advantages of SSD over HDD. Actually, SSDs are quite better than HDD. We can see in terms of durability and reliability of SSD. Actually, majorly you can see that SSD are quite reliable and durable than SSD. You can read the data in their slides written here, and we can say that HDD also consumes more power than SSD. So SSD can be widely used in today's modern days over HDD. We can say there are also some major advantages of SSD over HDD, such as less data and no voice. The SSDs are quite faster than a hard drive. So we can see in the slide that SSD are up to 100 times faster than HDD, and SSD often shorter boot time to a system. The computer is quite fast if running on SSD. Everything is quite faster when you use SSD comparing on HDD. It's totally mentioned that they are about 100 times faster than HDD. Let me move to the next slide. You can read all the data that is written here. You will find better, understand better how SSD are faster than hard drives, and SSD works on better speed or something. Just like you can say that they are quite improved version of HDD. Let me come to the next slide. Actually, wait, we have seen these slides. GPU. It is the most important component which is totally used in today by people who play games such like who do graphics related work. Just it is mentioned that it is a processor optimized for 2D, 3D graphics, video, visual computing, and display. It is highly parallel, highly multi-threaded, multi-purpose, optimized for visual computing. It provides real-time visual interaction with computer object-wide graphics, image, and video, such like that. Heterogeneous system combined in GPU with the CPU, such like we can move to the next slide where we are going to see the history of GPU. Actually, graphic processing unit came to the high performance enterprise computers in the late 1990s, and NVIDIA introduced the first GPU for personal computers, the G4256 in 1999. Over the time, the processing power of GPU has made the chip size a popular choice for the other resource-intensive tasks unrelated to graphics. Let me move to the next slide where we are going to see types of GPU. There are mostly two types of GPU. The one is dedicated GPU and another is integrated GPU. Firstly, we come to dedicated GPU. It is also known as discrete GPU. Dedicated GPU always has their own memory, cooling solution, everything. This helps the free resources for CPU to process information, which helps to avoid frame rate issue when playing games, editing videos, and doing a lot of stuff related to the graphics. Then we come to the integrated GPU. Integrated GPU is a GPU built into the processor. It is present in the processor. It is integrated. You can see in the name. It is integrated. Integrated graphic hardware does use a separate memory bank for graphics and videos. Instead, the GPU is a system memory that is shared with the CPU. Let me come to the next slide where we are going to see PSU, and it will be continued by my team member who will take over me and will tell you about power supply unit and everything. Thank you. So we will take.
Hello, my name is Sundram, and I will discuss about power supply unit. A power supply unit converts main AC to low voltage regulated DC power for the internal components of a computer. Modern personal computers universally use switched mode power supply. Some power supply have a manual switch for selecting input voltage, while others automatically adapt to the known voltage. And next, history of power supply unit. The power supply unit industry dates back to the early 1920s when crude devices were first developed to serve as the battery eliminator to power radio in both the commercial and consumer markets. The market for separate power supply evaporated around 1929 when most radios manufactured included built-in the power supply. And next, types of power supply. There are two types: AC power supply and DC power supply. AC power supply are used in supplying alternating current to an electronic device. DC power supply. A DC power supply provides direct current voltage to power and test a device under test, such as a circuit board or electronic product. Now my friend Manoj will discuss about cooling CPU.
Hi, I'm S. Manoj and my roll number is 23BDS056. So my topic is cooling CPU. Let's see the introduction of it. Cooling CPUs ensure the performance of computer. There are two types of cooling CPUs, air coolers and liquid coolers. Air coolers use fans and liquid coolers use closed loops, and they ensure the overall performance and longevity. This is history of cooling CPU. First, passive to active cooling. CPU cooling involved from passive heat sinks to active methods employing fans for enhanced heat dissipation as process became more powerful. Technological advancements. Heat pipe technology improved heat transfer, contribution to more efficient cooling solutions over time. Liquid cooling emergence. Now, liquid cooling emergence is the latest thing, and enthusiasts great setups, and then accessible all-in-one configurations offered superior heat dissipation. This is the best, and this is the latest one. These are types of cooling CPUs. First are air coolers. As you know, they use fans to cool, and second one are liquid coolers. These are latest and are used by most of the YouTubers and most of the streamers. They use higher pieces or something. Next is phase change coolers. Use phase change principles to cool CPU by transmitting a refrigerator liquid or gas states. These are not usually used. Next are thermoelectric coolers. Utilize a Pelletrix effect to create a temperature differential, drawing heat away from the CPU. These are types of cooling CPUs. Advantages of using coolers. You already know temperature control is the main motto of using coolers. And second one is enhanced performance. If the heat is not high, then the computers perform very fast and they maintain high performance. Extended lifespan. Yeah. If your device do not get heated whenever you use, the longevity of the devices increase. Next topic is input and output devices. Input devices allow users to interact by entering data or commands, while output devices provide information in various forms. This communication is crucial, enabling users' interactions, access to information, and feedback for the system, contributing to a user-friendly computing experience. So this is the history of output devices. Early output devices, computers initially relied on punch cards. You know it. Monitors and display screens. Display screens are the 21st century thing, evolved from monochrome displays to high resolution color screens, offering advanced visual output. Audio and advanced visual technologies. Audio output with built-in speakers and headphones, and recent advancement in 3D displays and VR technologies for immersive experiences. This is output devices, and this is history of input devices. Early mechanism. Initial input devices involved punch cards and paper tape to feed information into computers. Whereas now, we use keyboard, mouse, scanner, microphone to input the data. Keyboard and mouse, we already mentioned it. Touchscreens and gestures. These are not the latest things. Touchscreen and gestures will evolve. It is the greatest thing, providing more direct and interactive ways to interface the devices. That is it.
Hello everyone, I am Sahit Prakash Malkinda. Today I will tell you about the expansion cards. Expansion cards are circuit boards that can be inserted into specific slots on a computer's motherboard to enhance its capabilities. They connect to the motherboard through various interfaces like PCA, Peripheral Component Internet Connect, as we discussed before, and allowing users to customize and upgrade their computers based on their needs. Examples of expansion cards include graphic cards, sound cards, network interface cards, and storage controls, etc. History of expansion cards. In the early 1970s, expansion slots began to appear in PCs, such as the Athlete 8800, which allowed users to add functionality like extra memory, serial ports, and floppy disk controls through expansion cards. In modern era, like peripheral component Internet Express, simply called as PCIe, replaced PCI and HGP as a standard expansion card interface, offering significantly faster data transfer rates, supporting a wide range of devices from GPUs to sound cards and network cards. Types of expansion cards. As we see here, there are some common types of expansion cards like graphic or video card. It enhances the graphics capability of a computer, enabling high quality gaming, video editing, and more. Sound card improves audio quality and processing, used for better sound output, recording, and editing. Network interface card, as we discussed before, facilitates network connectivity, enabling wired or wireless internet connections. TV tuner cards allows the computer to receive TV signals, enabling television viewing and recording. USB or Firewire card adds more USB or Firewire ports for connecting external devices. Now let's go into ports and connectors. Ports on other devices are physically or virtually interfaces used to connect a peripheral or other devices. They allow data transfer, power supply, or communication between devices. Common types include USB, HDMI, Thunderbolt, and Ethernet ports. Connectors are the physical components that fit into ports, establishing the link between devices. They come in various shapes and sizes, designed for specific ports. Let's go into the history of the ports and connectors. Evolution of ports and ports include have been evolved from basic singular purpose connections to multifunctional and versatile interfaces. Initially, computers and devices had separate ports for different functions like serial ports, parallel ports, and VGA ports. With technological advancements, USB, commonly known as a universal serial bus, became a standard for various connections, supporting data transfer, power supply, and peripheral connections. Further advancements led to USB Type-C, offering higher data transfer speeds, power delivery, and compatibility across a range of devices. History of ports and connectors. The history of ports and connections is marked by the push for standardization to ensure compatibility and ease of use. Standardization efforts aim to create uniformity across devices, enabling users to connect different hardware with needing specific adapters or unique cables. Now, adapters and converters have become necessary to bridge the gap between old and new ports, ensuring backward compatibility and device adoption. Types of ports and connectors. We have mainly 7 to 8 types of ports and connectors. The first one is USB, Universal Serial Bus, used for connecting peripherals such as keyboard, mic, external devices, storage, etc. High definition multimedia interface, commonly known as HDMI, transmits high definition video and audio. Thunderbolt, it supports high speed data transfer and can also carry video and power. Display port, similar to HDMI, used for video and audio transmission, but commonly found on computers and monitors. These are some of the common ports and connectors, each with its own specific purpose in connecting various devices or transmitting data. Now my friend Manoj will continue with his operating system.
Yeah, I'm Manoj once again with you. So this is the last topic in our agenda, top 13 operating systems. Let's start with the introduction. An operating system, OS, crucial software managing computer hardware, bridging user applications and hardware. It oversees tasks like memory and file system management, device communications, and process scheduling. Examples include Windows, Mac, and Linux, and Android, ensuring seamless software and hardware interaction for user-friendly computing. Let's understand the history of OS. From 1950s to today, sophisticated mobile and desktop OS, the evolution is remarkable. IBM's OS 360 or Unix, or MS-DOS, Windows, Linux, and mobile OS mark key milestones. These are the biggest achievements in the OS development. Advancements prioritize multitasking, security, and user interfaces. These are types of OS. The evolution of operating systems is a journey of reflecting the dynamic relationship between hardware and its capabilities. So the OS journey from 1950s machine language to today's Windows 10 or Mac OS, Linux, and mobile OS reflects dynamic hardware user interplay. Batch processing, IBM's Unix and MS, Windows evolution, Linux rise, and mobile dominance mark key epochs. Adaptability to tech advancements remains paramount. Today's Windows 10 remain a leading desktop OS. Everyone tends to use it because OS is really high in price, and Windows is easy to get and use it. So that was our set, guys. This is how, and this are the main components you need to understand about to build your own PC, and you have to be sure about the prices and what kind of advancements you are using and what kind of technology you want to use it. So this is group 12. Signing off. That was our set, guys. Thank you.